Hello Year 11. Today what we are looking at is trigonometric identities. Our learning goals are to prove and apply Pythagorean identities, know the difference between an equation and an identity, use the fact that tan x equals sin x over cos x, provided that cos x cannot equal 0, and prove trigonometric identities. So the first thing we're going to look at is our reciprocal trigonometric ratios. So the reciprocal trigonometric ratios are the reciprocals of the sine, cosine, and tangent ratios. Our first trigonometric reciprocal ratio is cosecant. We write cosecant as cosec, and this is equal to 1 over sine, meaning that its ratio is the hypotenuse over the opposite side. How we can remember that cosec is 1 over sine is the third letter in sec is the first letter in sine. Our next one is secant, and we shorten this to sec. So sec theta equals 1 over cos theta, so that is equal to our hypotenuse over our adjacent. How we can remember that sec is equal to cos is that our third letter in sec is C, and our first letter in cos is C. Our next one is our cotangent, and we call this cot or cot theta. So cot theta is equal to 1 over tan theta, which is equal to our adjacent side over our opposite side. And how we can remember this is that we have that cot is equal to 1 over tan theta. Now, if you were to get out your reference sheet and turn to page 2, underneath our trigonometric functions, we have our trigonometric identities. So our first one here that we've been given is sec. Then we have cosec. And then for cot, we have that it equals cos A over sin A, which we'll come back to in a second. So the reciprocal ratios have the same signs as their related ratios in the different quadrants. So for example, this means that in the third quadrant, we have that, and the fourth quadrant, we have that sine theta is less than 0, meaning that sine theta is negative. So that means that cosec is also negative in those quadrants. What we're going to do for our first example is we're going to find cosec theta, sec theta and cot theta for this triangle. The triangle actually has an alpha there, but that does not matter. We are still talking about this angle here. So what we have is we need to label the sides of our triangle to start off with. So what we have is we have our hypotenuse, we have our opposite side, and we have our adjacent side. So for cosec theta, what we have is that is equal to our hypotenuse over our opposite side. Our hypotenuse is equal to 5 over our opposite side of 4. For sec theta, this is equal to our hypotenuse over our adjacent side, and so that is equal to 5 over 3. And our last one, our cot theta, is equal to our adjacent side over our opposite side, so that is equal to 3 over 4. Just remember that cosec is the reciprocal of sine, sec is the reciprocal of cos, and cot is the reciprocal of tan. For our next example, we've been given the trigonometric identity that sine theta equals negative 2 on 7, and that tan theta is greater than 0. We want to find the exact ratios of cot theta, cosec theta, and sec theta. So what we have to do is our theta is already on our triangle for us. We need to put our sides on. We know that sine is equal to our opposite side over our hypotenuse. So that means my opposite side from theta is 2, and my hypotenuse is 7. Now, what we have is we have that our sine theta is negative. So what I'm going to do is I'm going to draw up a little ASTC symbol down the bottom here. And because we have that sine theta is negative, what that means is this could be in our T or our C quadrant, because that is where sine is negative, but we are told that tan is positive. So because tan is positive, we are going to be working out of that third quadrant here. Now, we need to find our adjacent side of our triangle. We know our opposite side and our hypotenuse. So we need to find our adjacent side. And how we're going to find our adjacent side is using Pythagoras. So we all should know that our Pythagoras theorem is c squared equals a squared plus b squared. So what we have is our c is always our hypotenuse. So c squared equals our a squared plus 2 squared. So a squared is equal to 7 squared minus 2 squared. A squared is equal to 45. Oops. And a is equal to the square root of 45. Now, if you have one of the new calculators, you can put square root of 45 into your calculator and get that it simplifies down to 3 root 5. If you don't have one of the new calculators, you need to think to yourself, what perfect number, 1, 4, 9, 16, 25, can I divide 45 by? And we can divide it by 9, and we're left over with 5. And so that is how we get our 3 root 5, because root 9 is just equal to 5. Now what we want to do is we want to find out what cot theta equals, cosec theta equals, and sec theta equals. So cot theta is going to be positive because we are in our, I'll just put my 3 root 5 over on my triangle. Because we're in our tangent quadrant, and because cot is equal to 1 over tan theta, which is equal to a over o, what we have is that is going to be positive. So cot theta is going to equal, it is going to equal 3 root 5 over 2 once it pops back up in a second. 3 root 5 over 2. I'm actually just going to move this up because we're going to have a bit of working out to do. Oops, forgot the C. Okay, so now we want to work out what cosec theta is. So cosec theta is, our third letter in cosec is S. So this means this is 1 over sine theta, which is equal to H over O. So that means this is going to equal our H side of 7 over our opposite side of 2. Now, sine is negative in this quadrant, in our T quadrant, so we need to put in a negative in there. And finally, we have sec theta is equal to 1 over cos theta. So that is going to be also negative because we're in our tan quadrant, and 1 over cos is equal to H over A. So this is equal to negative 7 over 3 root 5. Now, if we could simplify any of these, we would. We can actually rationalize the denominator of this last one by multiplying the numerator and the denominator by root 5 to get our answer of negative 7 root 5. All over 3 times 5 is 15. Okay, moving on. If you need